For question 16-15, we're asked to calculate the pH of the solution after mixing two different reagents together. We're mixing together 100 milliliters of ammonia, and we're mixing that with 100 milliliters of HCl. So ammonia happens to be a base, and HCl happens to be an acid. HCl actually happens to be a strong acid. So we're looking at a neutralization reaction. So what we need to do to figure out the pH of this solution is add those two reagents together, determine how much reacts, how much we have left over, and then determine the pH. So a step-by-step approach, right? Step one, we're going to mix those two together, and we're going to determine the moles that react. Then we're going to determine how much is left. Is it an acid or a base? And then we can determine the pH of the solution. So our general neutralization reaction for ammonia reacting with HCl would look something like this. Ammonia is going to react with HCl to produce ammonium chloride. So to figure out how many moles will react, I need to convert my concentrations from molarity, which is moles per liter, into moles. So we'll start with the HCl solution. For the HCl solution, I have a concentration of 0.13 molar, which is 0.13 moles per liter. And I have 100 milliliters of that solution, which is 0.1 liters. So I'll notice my units of liters cancel out, and I'm left with units of moles. 0.013 moles of HCl. Next, I'll calculate for the ammonia solution. For ammonia, I have 0.04 moles per liter. And I also have 100 milliliters, so 0.1 liter of that solution as well. And again, liters cancel out, leaving me with 0.004 moles of ammonia. So those two react in a neutralization reaction in a 1-to-1 reaction. So that means 1 mole of HCl is going to react with 1 mole of ammonia. Well, I've got 0.013 moles of HCl reacting with 0.004 moles of ammonia. So when I subtract, I'm left with 0.009 moles of HCl. Right, this is my excess reagent. Now that I've identified the excess reagent, I can find the concentration of that, and I can find the pH of that solution. So we have 0.009 moles of HCl, which is a strong acid. The new volume, right, we need to find molarity, which is moles per liter. The new volume is 0.2 liters because I add together 100 milliliters of ammonia with 100 milliliters of HCl for a new total volume of 200 milliliters, which is 0.2 liters. So my new concentration is 0.045 molar HCl. pH equals the negative log of my hydronium concentration. So the pH of this solution equals the negative log of 0.045. The pH of this solution after adding the ammonia and the HCl together and taking into account the dilution when I mix those two solutions together comes up to be 1.35. So this was a rather involved calculation. We had to look at what was the reaction taking place. It was an acid-base reaction. We had to figure out how many moles of base do I have present, how many moles of acid do I have present. After I mix those together, what do I have left? And then because I was changing the volume of that solution, I was also changing the concentration. So we had to find our new concentration of the remaining component, the HCl, and then we could find the pH of this solution.